Hello, everyone. Good morning. Welcome to the lesson on problem solving involving rational numbers. Now, we ask ourselves before we tackle on this topic, what have we learned so far? Somehow, we've learned of the different operations and fractions. Part of the operations and fractions are not just addition to division, but we also made utilize of the concepts of LCD. Then, By those idea, by those ideas, we utilize it to solve equations involving rational numbers. And aside from this, we also have added the idea of reciprocals. Now, what does it entail for us to proceed to problems involving rational numbers? Now, I'd like to show you an example of it. This is the situation. You and your younger brother have volunteered to paint a wall of a community center as part of a community service project. I know you guys know what I mean, right? We are looking at painting a wall. Now, you could paint the wall by yourself in 3 hours. Your brother, who has less experience in painting, could paint the wall by himself in 6 hours. Now, how long will it take to paint the wall if you and your brother work together? So that's kind of uh, a problem which we can just use or solve mentally. We can do some estimations, right? So that's the first thing. We use estimation. Now, the upper limit on the time you and your brother take to paint the wall is the time it would take the faster painter to do the job working alone. So since you are the faster painter, then we can say generally that you are the upper limit, right? That you can paint the wall in 3 hours. Now, because you are the faster painter and you can do the job in 3 hours, you can estimate that when you and your brother are painting it, then it will take just less than 3 hours. Okay? Let me write those remarks on the side. So if you, which serve as the faster painter, will take just 3 hours to do the job, then that will serve as our upper limit. Okay? Meaning, what's the meaning of that? When we paint the wall, because we know for sure that you can finish it in 3 hours, then if your brother join joins force in painting the wall, then it should take both of you less than 3 hours. Okay? So your brother can do it in 6 hours. Okay? So if you can do it in 3 hours, then if your brother would add in the work, then it should take you less than 3 hours. Now, the second way to interpret the problem and solve it is using diagrams. So let's do some diagrams here. Basically, two diagrams, one for you and one for your brother. So if you are the faster painter, then this is the wall. I'm also going to do the same wall for your brother. So the same wall for your brother here. Now, your work rate when painting the wall is 1/3 per hour. Okay, what does it mean? So if I divide this wall into 3 parts, 1 and then 2 lines, so we have 3 parts. This means that you can finish the job in 3 hours, right? So this is your first hour right here. That's your first hour. Now for your brother, let's look at the perspective of your brother. So we can divide the wall into 6 parts. So we can have this one. Okay? So I'm gonna draw or color this side right here. This is actually the first hour for your brother. You see the difference? Okay? So your brother can finish the work in 6 hours. So meaning on the first hour, this is the only painted part that he can do. But for you, you can have on your first hour this much in terms of painting the wall. Okay, now there are actually similarities in the drawing. If you note, if you notice, okay, this part right here comprises of actually 2 parts in terms of your brother's partitions. So another 2 parts right here, which is on this side, and then another 2 parts right here, which is on this side right here. Okay? Now, what if both of you are then working? How do we picture out in a diagram? So let me divide this into 6 parts. So 1, 2, 3, 4, and 5. So let me draw it again. You can do this on your first hour because you are the faster painter, which we can finish the wall in 3 hours. But if you're working together, the first hour of your brother is then on this side. So this is the first hour of your brother, but for you, here is your first hour. Now, if we continue further, this will then be your second hour. So we now have almost painted the wall. So this is your second hour. And then, of course, since you're doing it both, the second hour for your brother is right here. Second hour. Now, question, have we fully painted the wall? Of course, yes. How long did it take for both your brother and you to finish painting the wall? It took you guys just 2 hours. So we were right about our upper limit, that it should be less than 3 hours for both of you to paint the wall. Okay? So we have 2 hours if you're working together. I hope the diagram helped you understand the problem and how we derive the answer. Now, there's another way of solving this, because sometimes diagrams may be taking so much time. So there's the equation. Okay? Now, just remember, work done is equivalent to work rate times time. So if you have 1/3 as your work rate, just like what we have shown here, this is 1/3, right? This is 1/3. This part right here is 1/6. That's your work rate. So how many 1/3s do we need to finish the job? Look at the drawing. Oh, sorry. How many 1/3s do we need? We need 1, 2, 3 1/3s. So we need 3 hours for you to finish the job. And in here, we have 1, 2, 3, 4, 5, 6, 6 1/6 for you to finish the job. So it entails 6 hours for you. So that's the meaning of work rate times time equals work done. Now, if we multiply 1/3 to time, that's then t over 3. Same with 1/6 times time, that's t over 6. Now, let's show our solution right here. If U has a work done equivalent to t over 3, and for your brother, he has a work done of t over 6, and if you work both, so that means you plus your brother can finish painting one wall, right? That's the meaning of it. So then we replace it with the equivalent. So this is t over 3 plus t over 6 equals one wall. Okay? Now, notice that we now have this equation, which is actually our past lesson. What lesson? Equations involving rational numbers. So these are rational numbers right here. Then how do we do it? We can actually use the idea of LCD. But what are we going to multiply here? What is the LCD? So we need to go back to the idea of the LCD. So we'll have LCD right here. We use the numbers, the denominators, 3 and 6. So we think of a number to divide for both 3 and 6 in which there is no remainder. And that is actually 3. Is it? Let's try. 3 divided by 3 is 1. 6 divided by 3 is 2. And there you have it. All your answers are whole numbers. Now, if you multiply everything to get your LCD, that's 3 times 1 times 2. This will give you an LCD of 6. So it means then that we need to multiply the equation with 6 to solve the problem. So let's then distribute 6 and multiply them to the fractions or the rational numbers. Okay, let's do some computations on top. Let's look at t over 3, times 6. The other one is t over 6 times 6. But with 6 times 1, I will no longer show that because that's very easy. So we can just do this first. So if we cancel 3 and cancel 6, that gives us 2. So 2 times t, that's 2t. Then cancel 6, that's 1. Times t, that's t. So we can now go back to our equation and replace those rational numbers or fractions. We just have 2t plus t. And then I said 1 times 6. We no longer have to show that on top because that's just 6. Now, notice 2t plus t. It's like having 2x plus x, which is just equivalent to 3x. Or like 2x plus 2x, that gives you 4x. So if we have 2t plus t, that means 3t equals to 6. We're almost there. That leads us to multiplying 3 with a reciprocal for it to become 1 beside t. So this is 1/3. And we also do the same on the other side. So that gives us then 1/3 times 3 is just 1. And 1 times t is just t. There's no need for us to write 1 because it's self-understood. Then we multiply 6 times 1. That's 6 divided by 3. That gives us 2. Now notice t is equals to 2. What is t again? That is time. So meaning, if we added you and your brother in terms of your rates, we then have confirmed it using equation. That means it will take 2 hours for both of you to finish painting one wall. Okay? So we review. I'll go back a bit to the slides that we've had. So the first one would be to look at the estimate. So we say if you can do it in 3 hours and your brother can do it in 6 hours. So if you are doing it both, if you're helped by your brother, then it should be less than 3 hours. Then using the diagrams, we have this. And if we combine your work, we can visually see it that it's really 2 hours. But if you can do the equation, okay, because sometimes doing diagrams would take time, then just remember work rate times time equals work done. Work rate times time equals work done. Okay, so we review that we can do estimation first, and then the second we can do diagrams, and on the third part we can actually do equations. Again, work rate times time, sorry about that, equals work done. And that's about problems involving rational numbers. Thank you so much, and good luck on the next task on worksheets.